In this topic, we will look at how to sketch curves expressed in polar form. You may find it helpful to have some polar coordinate graph paper handy. However, you will also need to be able to do this freehand. We're going to plot the curve of the polar equation 4r equals theta. We're going to start off by completing a table with values of theta going from 0 to 2 pi, going up in steps of pi by 8, and calculating what r would be for each of these theta values. So using a calculator, these are the values that we get. We're now going to use some polar graph paper. Now the polar graph paper starts with 0 on the initial line here. So 0 is on the positive x-axis. It then goes around in steps of pi by 8 until we get round to 2 pi. The concentric circles in the middle represent r values. We need to pick a suitable scale for this, just as you would with an x or y axis. Now if we choose each circle as being an additional 0.2, this will then fit the curve that we want to fit on. So the first point, 0, 0, represents the pole. We're then going to go around to an angle of pi by 8 and find 0.1. So if we're using a scale that each concentric circle is another 0.2, we're going to be going halfway. Then going to go around to pi by 4 and an r value of 0.2. And then 3 pi by 8, and so on. So you can see that when we get to pi, we've gone half a turn round. We are now at 0.79, which is almost 4 spaces out. We can therefore continue in this way until we get round to 2 pi. So this is the curve 4r equals theta for values of theta between 0 and 2 pi. We could continue this beyond 2 pi by continuing to substitute in values of theta. And this gives us a spiral. In this example, we're going to plot the curve of the polar equation r equals cos 2 theta for theta values between 0 and 2 pi. Now, because this is a function of cos theta only, or cos 2 theta only, we know it's going to be symmetrical about the initial line. So we actually only need to consider values of theta between 0 and pi. We can then reflect the curve below the initial line to get the other half of the curve. So here's a table of values of theta going from 0 to pi and the corresponding r values. We can see that some of the r values are negative. So when we go on to plot this curve here, notice that for some of the r values, well, we've got a negative r value for some values of theta. So for example, between theta equals pi by 4 and theta equals 3 pi by 4. So this is from here as far round as here. The r value is negative. So what's actually happening is we are drawing part of the curve in the opposite direction to the angle that we are considering. So actually the part of the graph corresponding to theta being between pi by 4 and 3 pi by 4 is the loop below. When we reflect the curve so that we can draw the other half of it, so the values from pi to 2 pi, we will get another set of negative r values. This is for theta between 5 pi by 4 and 7 pi by 4, which is this theta value to this theta value, and this corresponds with the top loop of the curve. So here, this is the part of the curve corresponding to theta from 0 to pi by 4. This part corresponds to theta being pi by 4 to 3 pi by 4. This part is then 3 pi by 4 to pi, then pi to 5 pi by 4. And then we have some more negative r values. So from theta being 5 pi by 4 to 7 pi by 4, we get this loop up here. Then finally, from 7 pi by 4 on to 2 pi, we get this loop here. Sometimes we might be asked to sketch the curve for r greater than or equal to 0 only. In this case, we would leave out any sections where r was negative, and therefore the graph would become this. Now complete exercise 6a on page 115.